Okay, this is the quick review of half-life. So we've got a problem. If the half-life of carbon-14 is 5,730 years, and there were 5,000 atoms of carbon-14, how many atoms will remain after 50,000 years? Right? Hypothetical question. Hypothetical because of the 50,000 years. Okay, so remember, a half-life is an exponential curve, and if I were to show the graph of the half-life and I were to show that as a function of time, then the curve would look something like this. It's an exponential decay, and time would be here, and the amount would be the other axis. And so as time increases, you can see how you're getting down to this part of the curve. And it doesn't take long to get there. You know, it doesn't take long at all to get down there. And so the accuracy of this method is tough because you get down at that low end of that curve. All right, we got another formula. There's two ways to write the formula. First way is like this. A, the total, equals C. C is the initial amount. Remember, the multiplier is always the initial amount in these exponential formulas. The base is 2, and because the base is 2 for half-life, we have to make the exponent negative. That's the same thing as a 1/2 base. All right, and then divide by the capital T. Capital T is the half-life. So capital T is the half-life there. Okay? All right, the other formula takes into account the half, and therefore then the exponent is positive. Time t divided by half-life, capital T. Okay, so now we just have to run the numbers. All right, so our total amount is going to be a factor of the initial amount, the 5,000 atoms, times, and again, you can do it either way. I like the half because now I have a positive exponent, and you can just do 0.5, right? A little bit easier. What's our time? 50,000 years. And what is our half-life? 5,730. So just a reminder what half-life is. That means every 5,730 years, half of the substance remains. Half of the substance remains every 5,730 years. So we're going to try to figure out how much is left after 50,000 years. All right? How much is left after 50,000 years? Okay, so you run the formula. Be careful. You got to be careful. Again, we have an exponent. My preference is to do this part in the calculator first. Actually, I figured out the exponent. I stored it. Then I did 0.5 to that power, and then I multiplied it times the 5,000. When it's all said and done, we end up with 11.8 atoms. That's all that would be left after 50,000 years, because you'd go through almost 20, 19, 17, something like that, half-lives of going half, 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 16, 17, 18 times, and so we're left with 11.8 atoms. We are definitely down at this lower end of the curve. All right, half-life, got to know the formulas, you got to know how to run them.